All right, so we're going to take a look at OpenStack Horizon, and we're going to go through the journey of deploying a virtual machine instance just the same as you would if you're going to deploy some workload on top of OpenStack. So right now we're logged into OpenStack Horizon or OpenStack Dashboard. This is the web interface for OpenStack. This is part of the open source OpenStack project. At this time, OpenMetal delivers this software to you unmodified. It's the same as you would get if you deployed OpenStack by yourself on another platform or on your own hardware. What we're looking at right now is a view of all of the currently running instances on this OpenStack cloud in this OKD account. These instances are all virtual machines. They are all complete virtual server environments running their own operating system, running their own software. So they're really the basic building block for how you deploy workloads on top of OpenStack. That if you've got some software you're going to run, you're going to set up a virtual machine instance in most cases and then deploy the software on that instance. So let's go through the instance creation process. So before you can launch an instance, you have to have a number of other OpenStack resources set up. The first thing you have to have set up is a router. So we'll go ahead and create a new router. So we just go to the routers page in Horizon. You click on Create Router in the top right, and you get to this router dialog. You can leave all of these checkboxes checked. They're fine. They're good to use the defaults. We have to select an external network. We're going to select this network called external that the OpenMetal system sets up for you. And what this does, this tells OpenStack, hey, take this router and connect it to this network that connects to the external internet. So we will create that router. Takes a couple seconds to get it done, but once it's done up, we will see a second router in this list. So there's our new router. And now we need to create a network. So we go to the Networks tab over here on the left, and you'll see a list of your existing networks. There's that external network we used just a moment ago to create the router. You can ignore this other network. That's for something unrelated to this demonstration. So click on Create Network here in the top right. You'll see another dialog box. And we'll just give it a name, new network. Leave all of these options as they are. Don't adjust them or change them. We have to give the subnet a name. We have to give the subnet a network address, so a set of IP addresses to use. This is a private subnet, so I would recommend using IP addresses that start with either 10 or 192.168. It's one of these kind of private IP address network ranges. So we're going to do 10.254.0.0/28, we'll say. We're just doing a demonstration, so it doesn't matter in particular. And then we got to give it a gateway IP address. And there's also a tab for subnet details. You can leave these defaults. These are some for more advanced configuration for your OpenStack network. And we'll go ahead and click Create. And so this is going to set up a new network inside of the OpenStack network space. So one of the most powerful things about OpenStack is that it runs its own networking space inside of itself that it uses for connections between virtual machines, other OpenStack resources, and it translates the requests going in and out to the external internet and within this network for you. And this is really valuable and powerful because you can give individual users the ability to set up complex network architectures to secure their private data, to restrict access to special virtual machine instances, to reduce the attack surface, the amount of points that somebody can poke and prod to try to access your network or access your data, all on their own without having to change a hardware network device like a router or a switch, without having to contact somebody in the data center or talk to a systems administrator. You can manage all of this stuff yourself. You can make networks, you can make routers, you can connect virtual machines to them, and have your own setup to meet your own individual needs on your own time without having to wait for somebody to sign off or approve. And that's a really, really powerful feature that you can't get in a many public cloud environments unless you pay a premium for that. So we've got our network, we've got our router. Now we need to plug that new network into the router. So we're going to go back to the routers page. We're going to click on our new router here. That'll take us to the details page for the router. and we're going to look for the Interfaces tab. So click on Interfaces, and these are all of the interfaces that are plugged in, you could say, to the router. And we need to plug in that new network we just made into the router. So when you click on Add Interface, you'll see this new box show up. It'll have some options for some subnets that you can plug in. We've got our new network right here. We click on that. You don't have to fill in the IP address. OpenStack will take the IP address automatically for the gateway that we set when we created the network, and then click Submit. So what this does is this tells OpenStack, hey, take the traffic from this network and send it over this router. And this is extremely important if you want to be able to access the public internet, if you want to be able to have your virtual machine instances access other instances on different networks attached to the same router. And we can take a look at what this looks like in practice by going to the network topology option here in Horizon. This is going to give us a very nice graphical representation of the different network assets that are set up right now in this project. So we have our external network here on the left. That's the network that maps onto the physical data center network, and that gives us our connection to the external internet. These little boxes with the lines in them are routers. So this is our new router that we just created. When you mouse over it, you can see some information about the router, like the interfaces that are connected, router status. And then you can see this green line going from the router to the new network. This is this new network we made. So we're going to attach some instances to this network. Once we do, they'll show up in this diagram. You can see an example of what this looks like on this orange network. Each of these little boxes is a virtual machine instance connected to this network. So let's create our instance. So we're going to go to Compute here on the left. We're going to go to Instances, click on Instances. And then we're going to click on Launch Instance over here towards the right-hand side. So when you click on Launch Instance, you're going to get a new dialog window. And this is going to have all the information for entering in instance information and giving it a name, description, different kinds of things like that. So we will say new instance. Description isn't required. It's just so that you can know what an instance is about. We don't have to change the availability zone. You can just use the default. There's only the one availability zone. And we only want to make one instance right now that looks like this. So after we've picked out these details, we need to go to source. And the source defines the software or operating system or disk image that we use to create the instance. So the OpenMetal platform does provide a number of disk images, for convenience. They're for popular operating systems like CentOS 8 Stream, Debian, Ubuntu. This is analogous to you taking an installation disk or USB drive with an install disk burned onto it and using that to make this machine, to provision this server. So for the purpose of this demonstration, we're going to do CentOS 8 Stream. You can leave these other options. They're defaults. They're just for picking what kind of resource you want to use to create the instance. If you want to create a new storage volume, if you want to delete the volume when you delete the instance, and how big the volume needs to be, you can leave those as their default. These are for more advanced configuration cases. Next, we're going to pick the flavor. So you can click flavor on the left-hand side. So the flavors dictate the resources that the virtual machine instance will have. So virtual machine instances have vCPUs, RAM, and disk. That's pretty much all they have attached to them. And as you can see, these different flavors have different combinations of those resources. Some have a balanced mix of resources. Some have more CPU resources than RAM resources. And some have more RAM resources than CPU resources. And that's what these names generally correspond to. So the M names are for memory. The GP names are like general purpose, balanced. The C names are compute and are more compute oriented. For our demonstration, I'm just going to do a C1.micro flavor since it's just a simple little instance. And this tells OpenStack, hey, set aside these resources for this instance to use. So now we need to give it a network. So I'm going to give it that new network we created. And it's generally best to attach your virtual machine instance to a private network. You don't want to attach it to the external network directly. Some of OpenStack's networking features won't work properly, or the VM won't be able to communicate with other instances if you attach directly to the external network. And you also will consume a floating IP address when you attach to the external network. And we'll talk a little more about floating IP addresses later. So some of these other options you can skip on the side. You don't have to worry about network ports. That's if you want to give a virtual machine instance a specific network interface that exists in OpenStack's networking space. We do need to give it a security group. So security groups are another one of the powerful OpenStack networking features. A security group is essentially just a firewall for OpenStack at the network level. So these security groups tell OpenStack what types of traffic to allow to the virtual machine instance, to what ports, or what, using TCP or UDP or some other kind of protocol. This is how in OpenStack you would control who and what has access to your individual instances and how they have access to each other. So right now I'm just going to keep the default security group for this demonstration. I'm going to add this external SSH security group I created earlier. That'll allow me to SSH into the machine from anywhere. And I know you may be thinking, whoa, that's a security vulnerability, right? Well, it might be, but we're not using passwords for SSH. We're just using SSH keys. So as long as we don't have an undisclosed vulnerability in SSH, which does happen, but very rarely, we don't really have to worry too much about this. So I do have to give a key pair so that it gets, so that I can log into the server, and OpenStack will inject the key pair into the server as it's doing the installation and setup process. And these key pairs get saved into your account so you can reuse them. And then now these other options for configuration or server groups or schedule hints or metadata, you can disregard those for now. Those are all for more advanced configuration scenarios. So at this stage, we are ready to launch an instance. So we'll go ahead and click Launch Instance. So at this point, OpenStack's going to start doing its work. It's going to check and make sure that it has enough virtual resources to provision the instance. It's going to set up a storage volume on Ceph, which is the software we use to provide storage for virtual machine instances in OpenStack. It's going to allocate that storage. It's going to install the operating system. It's going to get everything ready. And if you're not familiar with Ceph, it is a open source software for building enterprise quality storage clouds out of your physical hardware storage. It's very nice. It's highly available. It's very data redundant. We configure Ceph by default to keep 3 replicas of all of your data. So that means for every bit of data you have stored in your OpenStack cloud, you can lose up to 2 hardware machines entirely and not have any data loss. You're still going to have a really bad time and you're still going to have service loss, but you won't have permanent data loss, which is really, really valuable and helpful. So this instance is now ready. As you can see, OpenStack got it all done. It's got the IP address. It's got the key pair. It says active. It's running. Before we can log into it, we have to add a floating IP address. So we click over here on this dropdown on the right-hand side, and we click Associate Floating IP Address. So a floating IP address is a publicly routable IPv4 IP address. And this is what you have to use to allow the public internet to access some VM instance on OpenStack. So we have to give this one. I got to allocate another one since it looks like I'm apparently out. So we'll go ahead and click Allocate. We'll pick from this pool, the external network pool. We'll allocate an IP address. We do include a small number of IP addresses in every single OpenStack cloud provisioned on OpenMetal. And you really shouldn't need a lot of floating IP addresses. It really isn't great to give every instance a floating IP address. In an ideal world, you would have most of your instances on private IP addresses on private networks, and then you would only give floating IP addresses to like your public-facing load balancer or to a jump station style of server that you use to SSH in and get access into your network. And so in many cases, you really only need 1 or 2 or 3, maybe 4 IP addresses for a single project. If you do need more IP addresses, we do have those available. We're happy to provide those and arrange those for you. So this public IP address is now assigned. So now we can SSH into the instance. So let me switch over my sharing to demonstrate that. All right, so I'm sharing my terminal window. Here we go. And I'll go ahead and zoom us in so it's nice and visible. All right, so I've got that IP address. So we'll do SSH CentOS at that IP address. And we are able to connect. So that is the key fingerprint that the instance created that you can get out of the OpenStack logs for the instance. So we'll go ahead and say yes. And here we are. This is a new instance that we've made. Running CentOS stream release 8. It has that name, new instance that I gave it, and it is now ready for us to install whatever kind of workload we need to run for our business. So go ahead and stop that. And that is the deployment process of an instance. Relatively simple and straightforward. Should be good enough for most use cases. Let me do a little quick bonus tutorial on how to set up a security group, because I did not cover that during the setup process. So to manage your security groups, you go to Network on the left-hand side of Horizon, and you go to Security Groups. So click on Security Groups. You'll be taken to the Security Group page. You should see a list of existing security groups. You can create a new one by just clicking Create Security Group. And a security group is just a collection of rules. And each rule defines some behavior for how OpenStack should handle network traffic. So right now, this security group that I created has 2 rules. They are both for egress traffic. So this means traffic that is leaving the virtual machine instance, going out to the public internet or to another virtual machine instance or somewhere else. It's going out. And right now it says any IPv4 traffic from anywhere over any protocol over any port going to any destination is allowed. And this is the same rule for IPv6 traffic. This is a good rule to have. This is a fine rule. It's not a problem. VM instances need to be able to access, in most cases, the external internet to be able to download updates, download software, communicate with external services. But if you did need to remove those rules, you can click the delete rule button to get rid of them. But let's add a rule for SSH. It's very simple to do. You click on the add rule button. It's going to take you to this new wizard that has some information on the right-hand side explaining what some of these different boxes mean. You can also mouse over the little question marks, and they'll show you what kind of input you can put in. So you have rules, and you've got all different kinds of rule options. The custom TCP, UDP, IC, and P rules let you specify custom ports and IP addresses for different things. Horizon helpfully has several pre-configured rules for common popular services and protocols like SSH, as you can see on the bottom. So we'll click on the SSH rule, and this will create a security group for port 22, which is the SSH port, from the IP address range that we give here. You do have 2 options. You can give it an IP address range, or you can give it a security group. Using a security group is a great way to automate your security rules. So like if you've got a collection of VMs that need to be able to talk to each other that are in the same security group, you can give them a security group rule, and they'll be able to talk to each other. When you make new VMs, when they have that security group applied, they'll get that access. But for our purposes, we need to do a IP address range. That's what CIDR is. It's the set of IP addresses that you're going to be communicating from. Since I'm accessing from home internet and I don't have a fixed IP address, I'm just going to do 0.0.0.0/0, which is all IP addresses, any IP address. And again, like I said earlier, this is not normally a problem for SSH because we only allow SSH access using SSH keys, which is usually pretty reliably secure means of access. So that rule is in place. So we just have to add it to our instance, and we go back to compute to do that, and then click on instances. And then from the right-hand side of the table for the dropdown for the instance we're changing, click on the arrow, and you should see about 7 or 8 down an option for edit security groups. If you click on Edit Security Groups, that'll bring up this nice little dialog where you can move the security groups around and adjust them and change them and make those corrections or adjustments to the network traffic. And those changes do take effect pretty quickly. Sometimes it can take maybe 5 or 10 seconds for the effect to come into full, or the change to come into full effect. And you do want to do edit security groups, not edit port security groups. Port security groups is for security groups for like fixed network ports that you've assigned to instances. And that's not what you want to do. You want to assign the security group to the entire instance, to all of the ports that are attached to that instance. So those are all the steps that go into creating an OpenStack instance. You can follow that, all of those different steps to get a virtual machine instance that you can use to set up your workloads. If you want to delete the instance, of course, you've got a couple different ways you can do it. You can either mouse over here, click on the drop down on the right hand side and click on delete instance. All of the other instances, all of the other options for the instance are here as well, like rebooting it or shutting it off or making other kinds of changes to it. You can also delete more than one instance at a time by checking the box on the left-hand side of the table and clicking on delete instance on the right-hand side. So we'll go ahead and delete that instance. And it's gone, just like that. So do exercise great care when deleting instances. It's very easy to ruin your workloads. But if you do happen to accidentally delete an instance, you can generally remake it from the storage volume that was allocated for the instance. But that's a topic for another tutorial or another video recording. But that's creating instances in OpenStack Horizon. You can absolutely do this through the command line. You can do this using tools like Terraform or Ansible or OpenStack Heat. You can use the API, but this is how you do it through the web interface.